Hey, what's up, everybody? You're listening to the Enterprise Architecture Radio. If you're thinking about organizational complexity and agility, if you're concerned about operational efficiencies and thinking of taking it to the next level, if managing innovation is one of your priorities, you've come to the right place. On this podcast, we talk about all of that and more. It's a jungle out there, and we'll attempt to navigate this jungle of frameworks, methods, and most importantly, enterprise architecture in practice. Let's talk about event-driven architecture today. If you have had any programming background, you must have definitely learned the observer design pattern. The observer design pattern was a behavioral design pattern that essentially worked on the publish-subscribe model. It allows an object to notify other objects that are also known as observers when its state changes. This is done by having the subject maintain a list of its observers and calling a specific method on each observer when this state changes. In simple language, there is an object called subject, and there are many objects called observers, and the subject knows about all these observers, and whenever an event occurs, it publishes information about the event to all these observers. If you scale this, what you get is the event-driven architecture. Let's talk about that a little bit. I started my career as a programmer, and the first programming language that I learned was C, and then C++, and then Java, and then C#. And most of these languages are not really event-driven. So there is a method called main, and when we run the program, main is called by the system, and then every single function that exists within our software program has to be called. So we have a sequential mindset. We think if there is a function, it needs to be called. And it's not far from the truth even when it comes to event-driven architecture. It's just that the methods are being called at the generation of an event. But then why should we even talk about event-driven architecture in the first place? Well, there are a number of benefits of this design pattern. The first benefit is loose coupling. Event-driven architecture allows for components to be loosely coupled. This makes it easy and new functionality can be added rather quickly. The second is scalability. Event-driven architecture enables systems to scale horizontally by adding new components to handle increased loads. It adds to resilience. Event-driven architecture allows for fault tolerance by isolating failures to specific components. So since everything is dependent on events, things which are not dependent on a specific event can still continue to function if there are any issues with the event. There's asynchrony, of course. Event-driven architecture allows for handling of events asynchronously. Multiple events can occur simultaneously, and actions can be taken based on those events. It allows for flexibility. You can dynamically add and remove components to the overall architecture. But the most important thing that I think that event-driven architecture enables us to do is real-time processing. And event-driven architecture allows for real-time processing of events, which is important in systems where low latency is critical. Timing is critical, where something needs to be done immediately as soon as an event occurs. We don't need to poll for that event to occur. So let's talk about some basic concepts of event-driven architecture. Going back to the observer design pattern, it had a subject and it had observers. The subject maintained a list of all the observer type objects. Every time a new object of an observer was instantiated, it was registered with the subject. What that means is it was added to the list of observers that the subject maintains. And when the state of the class changed, it called a method that sequentially informed all the observers that are there in the list. If we scale that a little bit, what we have is the event-driven architecture. So the first concept in event-driven architecture is a broker. Now, broker is similar to the subject object in the observer pattern because its primary job is to inform the observers, in this case it's called subscribers, about the triggering of an event. It is a fundamental runtime component that is responsible for event routing in a publish, subscribe, low latency and guaranteed delivery manner. So Different components, whether it's a subscriber or a publisher, are decoupled from each other and they communicate with each other via the event broker. The event broker watches for events to occur, and once they do, it informs the publisher. So it is not exactly the subject component in the observer design pattern, but it does slightly more than that. The next important concept is the event mesh. Now you might start with one event broker, but eventually you're going to keep adding event brokers if you have an event-driven architecture. What the event mesh does is it maintains a network of event brokers that dynamically routes events between applications, no matter where they're deployed. So you might have applications on the public cloud, you might have applications on your on-premise data centers, you might have applications that are beyond, SaaS applications or other applications that are published via APIs by other organizations, etc. The event mesh maintains a network of all these different applications that are publishers of events, and all the event brokers that exist that essentially route these events from publisher to subscriber and what have you, and allows for the orchestration of all these event brokers. And we'll get into the orchestration part in just a little bit. Another important concept in event-driven architecture is the event portal. So we've covered the event broker, we've covered the event mesh, which is essentially a network of event brokers. And then there is an event portal. Now, this is a GUI component within the event-driven architecture. An event portal allows you to define and design events in a governed manner and offers them for use by publishers and subscribers. So you basically look at the different publishers and subscribers that you have and create event brokers and create events and essentially architect your event-driven architecture using a GUI-based tool. That's an event portal. An event portal is a solution that lets people design, create, discover, catalog, share, visualize, secure, and manage events and event-driven applications. Event portals serve three primary audiences. You have architects who use an event portal to define and discuss and review the events, data definitions, and application relationships. You have developers who can use the event portal to discover, understand, and reuse events across applications, lines of businesses, and even between external organizations. And then the third audience is the data scientists who use an event portal to understand event-driven data and discover new insights by combining different events. So data analytics, essentially, right? So simply put, an event portal is a GUI-based tool that allows you to design the entire event-driven architecture. And then one last concept within event-driven architecture is event taxonomy. Taxonomy is basically a list of terminologies so that you can understand what you're talking about. Now, many people do their event-driven architecture without specifically writing down their event taxonomy, but it's a good idea to start with the taxonomy. Helps in the design, helps in communication between architects, etc. Now, these are the basic concepts. How do you get started with event-driven architecture? Well, you get started with a pilot application. Now, in all probability, you already have within your organization some kind of event-driven applications in place. Event-driven architecture is taking a look at all those event-driven applications and see how they interact with each other. The ideal thing to do is have an event-driven architecture end-to-end. So all applications within your system, within your enterprise, are event-driven. They are all loosely coupled, and they all react to events. And we orchestrate the events and the event brokers using an event-driven architecture portal. But that's the ideal goal, and in all probability, unachievable, but we always strive to achieve it. But when we start doing event-driven architecture, we start with a pilot application. We take a look at one application that can be turned into an event-driven application. The idea is to identify events and event flow. The event catalog, we create a list of all the different events that the application is either going to publish or going to respond to, and then then things start taking shape automatically. you could maintain the event catalog in a Excel spreadsheet, or you could use a sophisticated event portal, doesn't matter. In all probability, if you are thinking about event-driven architecture, you are starting with an event publisher, and you need to start thinking about all the different applications that are going to respond to the events that this event publisher is going to publish. The next step probably would be to look at how different applications are going to react to an event. Now, it's a good idea to have microservices, because when you have microservices, you have modularity, a more detailed modularity, that you have less dependencies, and it creates a loosely coupled architecture where, in case if some of the microservices are not working, the entire event-driven architecture doesn't come to a screeching halt. And this is where I introduce the concept of orchestration and choreography. So when you have microservices, you can orchestrate the microservices, or you can choreograph the microservices. And this is a concept that requires a more detailed explanation, but I will just give you the basic definition, which is when it comes to microservices orchestration, your microservices work in a call and response fashion, and they're tightly coupled. They're highly dependent on each other. They're tightly wired to each other, right? But with event routing choreography, microservices are reactive. So one microservice doesn't call another microservice. It communicates with other microservices via the event broking architecture. They respond to events. All the microservices essentially responds to events, which makes them loosely coupled, which means that if one application does fail, business services are not really dependent on each other. So, which means that if one application does fail, then all the microservices that are not dependent on that particular application continue to function. They don't have to come to a screeching halt. Now let's talk about the different kinds of applications that can be integrated into an event-driven architecture. The first one are the natives of event-driven architecture. They're called the event-driven applications. These applications can publish and subscribe to events and are aware of topics and event-driven architecture taxonomy. Now, what's a topic? A topic can be thought of as a channel or a stream of events which are associated with a specific subject or type of information. Topics are often organized hierarchically, which is there's a parent topic and there are one or more child topics. These allow for a more fine-grained control over the events that a consumer receives. So event-driven applications are topic aware. Then we have API-ready applications. These are not really event-driven applications. They may or may not understand the concept of publishing and consuming events, but they can be consumed via API. They publish their APIs. So we could have an adapter that could be an event-driven adapter that could understand the concepts of publish and subscribe, that could understand the concepts of topic, and this adapter could essentially call the API-ready applications and make them event-driven architecture aware. And then the third kind of applications that we have are legacy applications. These are classic monolithic applications that are not API enabled and they are not event-driven architecture enabled. How we can consume these applications in an event-driven architecture, or how we can integrate them, is a question that requires a more detailed answer. There are adapters that you could build that could integrate with these applications, but then it's a case-to-case basis. We'll have to decide. But and most of the times, these legacy applications are not integratable with event-driven architecture. It's not impossible to integrate them. It's a question that needs to be answered as to how much value we can drive by making them event-driven enabled, because there's a considerable amount of effort that is required to make them event aware. Now, this is an enterprise architecture podcast, and I need to make it relevant to overall enterprise architecture. Earlier, I talked about the concept of going end-to-end with event-driven architecture. And it's an ideal that we should strive for. But the question that arises is it really practical to go with an end-to-end event-driven architecture? This question is not specific to event-driven architecture. It applies to everything. It's service-oriented architecture. It applies to cloud-first architecture, all kinds of architectures. Is it a good idea to go end-to-end with any particular form of architecture? And if you really ask me, I don't believe that any organization or enterprise should take one paradigm and think of going end-to-end with it. I think the good idea would be to study on a case-to-case basis the enterprise, the nature of the enterprise, the nature of the business, the challenges that come along, and decide of an enterprise architecture that in all probability, for especially when it comes to large and complex enterprises, a mixed bag of different paradigms. Of course, there are startup organizations that are small and simple that may decide to go with a single paradigm. There are other organizations that may not be small and that may not be startup, but the business model is rather simple. Take Uber or Netflix, for example. They have a comparatively simpler business model, considering that their product line is simple. Let me give you an example of a complex and a simple business model. If you look at a non-banking financial organization, they have a simpler business model than a healthcare and pharmaceutical organization, because most of their products, in fact, all of their products, are digital in nature. On the other hand, in a healthcare and a pharma organization, you've got manufacturing capabilities, you've got supply chain, you've got regulatory bodies that you need to align with, and so on and so forth. So and then you've got manufacturing capabilities across geographies, which again adds to the challenge. So if you really think about it, there are some businesses which are by nature simpler than the other businesses. So in my opinion, whether it's event-driven architecture or whether it is any other paradigm that you might think of, we need to take it on a case-to-case basis. We need to look at the nature of the business. We need to look at where it makes sense to apply a certain paradigm. And if the nature of the business is simple, you may go with a single paradigm end-to-end. It could be event-driven architecture end-to-end. Every single application within your organization, completely event-driven, completely modular, completely responding to events as they go along. Or you may have a complex business model where event-driven architecture may not suffice. You might have legacy monolithic applications that you may have to deal with, and not all applications do need to be, well, at least time sensitive. Modularity is a benefit that every single application can benefit from, but we need to look at the costs. We need to look at the value that event-driven architecture drives in a specific business scenario, and then based on that decide whether it's a good idea to go end-to-end. That's event-driven architecture, at least the basics. Of course, it's a vast and deep subject that requires a more detailed discussion. There are various tools and technologies that enable event-driven architecture. We've got Apache Kafka, which has its origins in LinkedIn. We've got Solace. We've got various event-driven architecture tools on various cloud providers. It's always a good idea to be cloud native when you are doing event-driven architecture. And there's a lot more to discuss on this topic. Maybe if there is sufficient interest, I could isolate each topic within event-driven architecture and get more detailed about it. If you are one of the users of event-driven architecture tools or have considerable experience in the area, feel free to get in touch with me and we could have a discussion about it. I think that should be very interesting. That's all I have for you today, folks. I hope you enjoyed the show. More about organizational agility, innovation, and enterprise architecture in the practical world, in the business, right here on the show. But before I end the show, I want you to help me out with this one little thing. Pause the show and share this podcast via WhatsApp or text message with at least one person who might be interested in the show. It could be anyone, your colleague, your boss, someone in your team. That's all I ask. Just one share with one message via text or WhatsApp or any social media of your choice. And it would go a long way in supporting this podcast and growing this listener base. Also, please don't forget to follow the podcast. That way, you'll get notified when we publish a new episode. If you want to find out more about us, you can find us at enterprisearchitectureradio.com. If you have ideas, thoughts, disagreements, please feel free to write to me directly. We also have a Telegram group if you would like to contribute to the EA discussions or what have you. Just search for Enterprise Architecture Radio on Telegram. Or the URL to join the group is https://t.me/Enterprise Architecture Radio. While our contact details are there in the show notes, we are very easy to find. Just search for Enterprise Architecture Radio anywhere. Twitter, LinkedIn, Facebook, Instagram, YouTube, even Discord. Once again, I hope you had fun, and I'll see you in the next one.